Hi class, I hope you had a great weekend. So this week, finally, we are going to start to leave our own solar system and start talking about the search for worlds elsewhere and how we might look for life on those other worlds. Up to now, we've been largely focused on the worlds that are up close, the worlds that we can get to, the worlds that we can see in telescopes, places where we could actually do hands-on experiments. But certainly when we think about the search for life, we're often talking about life in the entire galaxy and where we might go and look for it. So that certainly is a staple for science fiction. And so we will begin with just understanding the stars, the connection between stars and planets. And then on Wednesday, we'll leap into how we actually look for other planets. Okay, so as I said, this is a staple for science fiction. The background here is the kind of typical thing that you see when you watch science fiction movies or television shows. You get a view screen on your starship. You travel to some world somewhere else in the galaxy and you encounter a planet that looks not unlike the planets that you have encountered here in our own solar system. And so this is an interesting part of this whole story, and it's one that we will come back to on Wednesday, but we'll start with today, which is our thinking about planets is largely informed by the planets that we have encountered here in the solar system. But as we will discover, those expectations aren't always necessarily correct. Okay, so let me go ahead and start a few slides. So we're going to start with a discussion of stars. So planets, as we discussed early on in the quarter, are born around their parent stars, and the stars are largely responsible for the environment and the energy that the planets have access to. And so we're going to start with a discussion of stars and then I'll lead to planets. The Milky Way itself certainly has the potential for lots and lots of planets. It is about 100,000 light years across. There are some 400 billion individual stars. And so if you were to imagine that every one of those stars had planets, that is an awful lot of planets. And so the beginning of our quest to understand those planets so that we can start talking about what life might be like on them is really about understanding the stars themselves, so we know where to look for planets and under what conditions those planets might find themselves. Okay, so I'll start today by just talking briefly about the discovery of planets here in our own solar system and how that set the stage for us to think about stars. We'll talk about the discovery of stars themselves, okay? And then we'll end with the launching point for how it is that we are looking for planets around other stars, okay? So planet comes from the Greek planestes asteres, which means wandering star. To your naked eye, planets definitely look like stars. And I don't know how many of you have done any backyard astronomy, but in general, at almost any time of the year, if you go out, there's usually a few planets you can see. And if you go look with your naked eye, planets do indeed look like stars. They're colored points of light, but they're just points of light. They don't have any structure or size the way something like the sun or the moon does. They're called wandering stars because they aren't fixed in single locations in constellations. Over time, they move across the sky. As you can see in this image here, sometimes they exhibit quite exotic motion across the sky. So this is a stacked set of photographs of Mars over the course of a season. You'll see Mars is slowly working its way through one of the constellations, and then suddenly it decides to start traveling the other direction in the constellation, and then eventually it decides to head back in the direction it was originally going. So this kind of motion, if you've taken intro astronomy before, is called retrograde motion. It's basically associated with the fact that Earth and Mars are both moving in their orbits, and at some point Earth passes Mars. And it's during that passing phase that Mars appears to be moving backwards, and then it starts moving forward again once Earth is past it. You can see this kind of effect when you're out on the highway. If you're driving, you and a car are initially traveling in the same direction together. During the time that you're passing, it looks like the car is moving backwards with respect to you, and once you're past it, it looks like it starts traveling in the same direction as you again, okay? Now, since antiquity, there have been 5 planets known. The classic planets are Mercury, Venus, Mars, Jupiter, and Saturn. All of those are visible to your naked eye, but they are the ones that have been known forever, okay? Now, all of that changed in 1609. So Galileo in 1609 had heard of invention what we today call a telescope, spyglass. It was something that was being tinkered with across Europe, and he had heard of a put together by a lens maker in the Netherlands called Hans Lippershey. And so Galileo took what he had heard and basically crafted his own, which you see here, and he began to experiment with it. Now, in those days, the telescope was imagined as a technology, as much technology is still today, with military application. If you could see your enemy from far away, that gave you a distinct advantage. But Galileo had the wherewithal to imagine that it might be used for other things. And in particular, he turned it to the sky. He was the first person to do so, which is why we often associate his name with the invention of the astronomical telescope. Now, he looked at many things through his telescope, and he discovered many things through his telescope. He wrote them all down in a book called Sidereus Nuncius, which is Latin for starry messenger. And he published that book in 1610 to great fanfare, and it is certainly a famous book that we still talk about today. Now, one of the things he did was he looked at the 5 classic planets. He looked at the 5 classic wandering stars, and he discovered they, in fact, are not stars. He was able to resolve that the planets were not little pinpoints of light, but the telescope showed him that they were actual worlds. They were disks. Okay, now that discovery, as I like to remind people, was not that the wandering stars were planets. We already called them planets. It's that the wandering stars were worlds. And so the planet he actually discovered is the Earth. The realization that the planets are worlds like the Earth really puts the Earth in the same class as all of those worlds. Okay, and together with the Copernican hypothesis, the idea that the planets orbit the sun, he set the stage for the search for planets in the entire galaxy. So this is really, in my mind, one of the great moments in the search for other worlds, and certainly led to the search for life that you and I are talking about. Okay, the idea that Earth is just one of many such places in the cosmos, and that many such other places must exist. There must be other worlds, possibly like the Earth, possibly not, that we can go look for life on. Okay. Now, the other thing that Galileo discovered was, in fact, the stars. Now, that sounds like a weird statement because the stars are clearly there if you go out and you look at the night sky, and that's true. If you go out and you look at the night sky, there are about 9,000 individual stars that are visible to your naked eye, okay? But what Galileo did was he took his telescope and he turned it towards areas in the sky where he could clearly see some stars with his naked eye, and it looked like dark sky all around them, okay? So this is a piece of what we generally call the winter sky. You can't see it right now because the sun is in this region of the sky, but near the end of the summer, if you get up in the early morning, you'll be able to see this. So here in the center, just to the left of center, is the constellation Orion. It's probably one of the most recognized constellations in the world. It appears in virtually every cultural stories of astronomy there is. It's easily noted by the 3 stars in kind of a horizontal line right there in the middle. That's called his belt. There are 3 stars kind of hanging vertically down from his belt. That's usually called the sword. And then the 4 bright stars around it are his shoulders on top and his knees on the bottom. And we'll come back to these in the next half of today's lecture. The bright red star, yellowish star at the top is called Betelgeuse, and the bright bluish star on the bottom is called Rigel. Okay, so this here is the constellation Orion. Now, if you go to the extreme right side of the page, you'll go through a group of stars there in the middle. That's called the Hyades. The bright yellowish one there is called Aldebaran. It's the eye of the bull. That's a constellation called Taurus. But over here on the extreme right, there is a little group of stars called the Pleiades, or the 7 Sisters. Many of you have seen the 7 Sisters before. If you look on the front of any Subaru car, their logo is the 7 Sisters. The Japanese call this constellation Subaru, which is where the name of the car company comes from. Okay, so what Galileo did is he turned his telescope, in addition to many other places, to the belt of Orion, and he looked at the belt of Orion, and he looked at the Pleiades. Okay, so here is kind of a naked eye map of Orion's belt and the naked eye map of the Pleiades. And what I'm going to show you is Galileo's sketch that he could see through a telescope, and the modern plotting of what the area looks like with a program, computer program, that can show you what a telescope can see. Okay, so this is Galileo's sketch of the area around Orion's belt. You can see the three large stars there that look like a sheriff's badge at the top. Those are the three belt stars. And you can see that compared to the naked eye view, he saw lots and lots and lots and lots of stars that had never been seen with the naked eye before. This is really the moment that Galileo was discovering the power of the telescope to show us things that we could not detect normally with our other senses. The ability of technology to extend human senses is really the key to our growth in our astronomical knowledge. And this is the moment when it first began. Similarly, here is a naked eye plot of the Pleiades. Okay, so down there on the bottom half of the page, so that looks kind of like the Subaru logo if you go look at your Subaru out in the driveway. And if you compare that to Galileo's sketch there, you can see again the sheriff badge kind of stars are the naked eye ones, and then the little black stars are all of the new stars that he could see through his telescope. And compared to the modern star map there, you can see he did quite well. Now, I should note here that the telescope he was using was not the greatest telescope in the world, right? The telescope that he used was really just the crummiest telescope you could imagine. It was not even nearly as good as a pair of birding binoculars that you have gathering dust under your couch right now. If you pull any old pair of binoculars out, they're at least as good as Galileo's telescope was. And if you take your binoculars that you're using to watch robins or blue jays or cardinals or whatever you're using them for, if you take, or football games, right? Take your binoculars and you go look at the moon, or you go look at Orion's belt, or you go look at the Pleiades, you look at anywhere in the sky that Galileo looked, your binoculars will show you what he was able to see. Okay, it does not take a giant telescope to discover that the universe is a much bigger place than we think if we just look with our naked eyes. Okay, now the other thing that he did was he pointed his telescope towards the Milky Way. Now, most of us probably live in cities, and so that means many of us have not seen the Milky Way. And if we were in class together, normally I would ask you to raise your hands because I'd like to know how many of you have seen the Milky Way. I grew up in the country. I grew up in rural Eastern Oregon. So I grew up seeing the Milky Way. And I'm completely unused to living in a place where you can't see it just walking out your back door. So here's a picture of the Chicago skyline. This is taken from the Adler Planetarium. This is a picture taken at night. Okay, and those of you who have been downtown Chicago at night, you know certainly there are not very many stars you can see. This is very typical of most modern cities in the world today. This is what we call light pollution. The light that we're using to illuminate our streets and our buildings doesn't just go down to the ground. Many of those lights we have pointed so that the light can go up, and then that puts light in the sky, and that light in the sky prevents us from seeing the stars. Now, if by some miracle there were a power outage in Chicago, or if we had decided we don't need all those lights on because we're all locked down in the middle of the global pandemic, then the night sky would in fact return. It is there behind the light pollution all the time. And you can see it if you can get to someplace dark. If you just drive a couple of miles out of town, you drive to a local state park or just on a highway that's away from cities, if you look up, you will see the Milky Way. And this time of year right now is getting towards the time of year where we can see the Milky Way. The whole summer season, the Milky Way will be visible, stretching overhead. Okay, so this is what the Milky Way looks like. It's this kind of diaphanous band of light that stretches from one side of the sky to the other. This here in this backdrop is the summer Milky Way. This is in the direction of the constellation Sagittarius. It's actually the center of the Milky Way galaxy, so it's the brightest part of the Milky Way. But to your naked eye, it looks just like a fog bank or a cloud, not unlike the way it looks in this picture. That faint blue and red glow you see there is what the Milky Way looks like to your eye. But Galileo pointed his telescope at that faint glow and discovered it's completely made up of stars. This is how we discovered that the Milky Way was in fact a gigantic collection of stars. And so what he wrote in Sidereus Nuncius is this. He said, the galaxy is nothing else than the congeries of innumerable stars distributed in clusters. To whatever region of it you direct your spyglass, an immense number of stars immediately offer themselves to view. They weren't visible before he pointed his telescope there, of which very many appear rather large and conspicuous, but the multitude of small ones is truly unfathomable. So Galileo was the first person to realize that that number of stars in the Milky Way was enormous. Today, we know it's something like 400 billion. There are a lot of stars and thus a lot of places for us to look for planets, a lot of places for us to look for other life. Okay? Which brings us to the point of if the stars are really there, so Galileo discovered the stars are there, and if we assume there are planets there, we need to know something about the planets too. Now, science fiction has imagined planets for centuries, okay? So Kepler, who was a contemporary of Galileo's, had written one of the very first science fiction novels, and that was the beginning of a long history of writing about traveling off of the Earth. And invariably traveling off the Earth involves landing on other worlds, other places, and science fiction, particularly in the modern cinematic era that you and I live in, has gone to great lengths to imagine all the different kinds of planets there might be. Now, my original note, I think, still holds, which is we aren't very good about imagining how planets might look different than planets that we have here in the solar system. Maybe that's right, maybe that's wrong. You know, the physics is the same out there as it is here, but the appearance of the planets doesn't necessarily have to be the same as they is here. Okay, we don't know yet because we can't see planets around other stars. Okay, but I could produce a list of planets, not unlike the one I've listed here, that is enormous. Okay, science fiction has imagined tremendous numbers of planets, and so you and I are going to take that belief and we're going to put some science on top of it. Okay, so there are in fact real planets. The first real planets were discovered in 1992. Okay, that is less than 30 years ago. The first ones discovered were discovered around a dead kind of star called a pulsar. So PSR 1257 plus 12 down there in the lower left. That was the first pulsar around which we discovered planets. The reasons for that are complicated, but it has to do with the fact that we can measure the location of the pulsar very accurately. We'll talk about that during the next class. That weird name is very typical of the names we give to stars in astronomy. It is basically the coordinates of the star on the sky. Okay, so the sky has coordinates that are like latitude and longitude. So the first number, the 1257, is called right ascension. It's kind of like longitude on the sky. The second number, either plus or minus, and then the number is like the latitude on the sky. So whenever you see a weird number like that, they're basically telling you where to go look on the sky to find that particular star. So the very first planets were discovered around this pulsar by Alex Wolskin at Penn State and David Frail. So it was a tremendous discovery because up to that point, we had only ever speculated that there were planets around other stars. We had never known definitively that there were. Right? Gene Roddenberry, George Lucas, all those folks making science fiction movies had been telling us, imagining that there were planets around other stars for decades, okay? But it wasn't until 1992 that we knew with certainty that there were certainly planets around some other stars, okay? Now, that launched the current search era that we live in for exoplanets around other stars. And in 1995, we discovered the first planet around a star like the sun. So that star is called 51 Pegasi. It's visible to your naked eye. It's about 50 light years away. And the first planet that we discovered around that star is called 51 Pegasi b. Okay, now that planet is unusual. It's about half the mass of Jupiter. That doesn't sound so unusual, but it's in a 4-day orbit. It's 10 times closer to its star than Mercury is to our sun. That's unusual, okay? And that was a great mystery to us when we first discovered it. And we'll talk about this by the end of the week. We'll talk about the architecture of exoplanet systems. In fact, the mystery seems to be, or it may be, that our solar system is weird and other solar systems are not. We'll come back to that probably at the end of the week, okay? Now, I will note that 1995, so that was 25 years ago, We started discovering planets around ordinary stars, not unlike the sun, but we still have not discovered any planet that is the size of Earth. Okay, and there are reasons for that, and we'll talk about those next class period. Okay, but as of today, as of this moment, okay, I looked it up right before I gave this lecture. We have discovered 4,266 planets around other stars. Okay, and that is in 3,152 distinct individual planetary systems. So those two numbers are different because some of the planetary systems we've discovered have more than one planet in it, just like our solar system, which is really exciting. Okay, so my point here for you, the main message that I want you to walk away with from this lecture is this. You right now are living in the age of planetary discovery. This is absolutely out there at the bleeding edge of what our best technological capabilities in astronomy are. Our understanding of the universe is changing right now in front of your eyes with the discovery of each new planet. When you were born, we had barely started discovering planets around other stars. And right now, as you work your way through your education, as you go on to your career, and as you live through the next few decades of your life, we are literally changing our understanding of planets, our understanding of our own planets and solar system, and what the implications for the search for life might be, which is kind of cool. You often can't say that about the big pieces of astronomy. Okay, so that's all I'm going to say for this part of the lecture. We'll be back for the second half of the lecture. We'll spend most of that talking about stars and the properties of stars. Basically, we're going to use that to decide what stars we're going to point our telescopes towards to look for other planets. And that's what we'll talk about next lecture. Okay, so I hope you're all doing well. Take care of yourselves, and I'll talk to you soon.